Right. Paper number 18. Velocity time graph question. A particle starting from rest moves along a straight line path with uniform acceleration a. As the particle reaches the velocity v, it strikes on an obstacle on its path. Due to the collision, its velocity reduces to v by 2 suddenly. Afterwards, it moves with the velocity v by 2, a distance d, and begins to retard with retardation 2a and comes to rest. So that the total time taken is 5v upon 4a plus 2d upon v. Also find the total distance traveled. If the average velocity of the particle is 5v upon 11, find d in terms v and a. Right. So VT graph here first location, it moves with certain acceleration a this way, time axis this is the velocity axis, right? This way moving. Oh, right, this velocity is v. And collision with the obstacle, the velocity suddenly decreases up to v by 2, like this. Then moves with constant velocity v by 2, right, this way. And then the retardation. Right. Retardation given as 2a. Right. If this angle is alpha, this angle is theta, then tan theta gives the acceleration simply, and tan alpha retardation 2a. Right. So I'll take this points. This is A, B, C, D, and this is E, and this is F. Right. So now first one you can calculate. This tan theta you can write opposite by the adjacent. Tan theta V by OB. Tan theta is really A. V over OB. The OB time then you can write V upon A. And also BCDE area, simple D given, no? BCDE area, simple D. BCDE area is equal to simple D. BCDE area you can write V by 2 into BC, no? V by 2 times BC is equal to D, then BC equals 2D upon V. And also this tan alpha ratio you can write V by 2 divided by CF tan alpha V by 2 divided by CF. Then you can write tan alpha is 2a V by 2 times CF, then CF you can write V by 4a. So then the total time going to be OB plus BC plus CF, no? Total time. Total time means OB plus BC plus CF, right? So then OB V over A, BC 2D over V, CF V over 4A. Right. So then here this and this we take together and take the common denominator as OA. Then this V should be multiplied by 4, and here V, and 2D upon V. This is nothing but 5V over 4A plus 2D upon V is the total time. Right. Now asking the next one. Also find the total distance traveled. Total distance traveled means this total area, no? This OAB area, BCDE area is simple D given, and DCF area, no? Right. Total distance traveled, right? Then this time we know V over A, BC time 2D upon V, CF time V upon 4A. Right. Okay. Now total distance traveled. Right. Total distance traveled is this OAB area and this area and this area, right? Total distance traveled. Hmm? OAB area plus D CDF area. Right. OAB area, you can write half basis V over A into height. BCDE area, simple D. The other one, half basis V upon 4A into perpendicular height is V by 2. Right. Okay, now simplifying here, we get V squared over V D here, V squared over 16A. Right, so then furthermore we can simplify taking the 16A as common denominator. Then here 8V squared and V squared 9V squared plus D. Correct, no? Right. Next one asking if the average velocity of the particle is 5B upon 11, find D in terms of V and A. Average velocity we write how total distance traveled divided by total time taken. Okay. So then the average velocity we can write. Average velocity given as, right, 5V upon 11. Average velocity is 5V upon 11. Average velocity we write total distance traveled, it is this 9V squared over 16A plus D divided by total time taken. Total time taken is 5V over 4A plus 2D upon V. Okay. Now by this we have to find this D, right? Now let's simplify this. Thereby we can take the answer of this D, right? Okay, then we get we use the cross multiplication by this 5V over 11 times 5V over 4A 2D upon V equals 9V squared over 16A plus D. Right. Okay. Then here we get 5 and 5, 25 V squared over 44A. Then here this and this, when you remove the bracket, we can cancel down. 5 and 2, 10D divided by 11. Correct, no? 10D divided by 11. 5 and 5, 5 and 2, 10. D divided by 11. We cancel down. and 9v squared of 16a plus d. Okay, now we'll bring this to this side. This to this side and this to this side, no? Right. 25v squared over 44a minus 9v squared over 16a d minus 10d upon 11. Right. Okay, then by simplifying this, you can take the answer. Right. Right hand side, you can take common denominator as 11, 11d minus 10d is d. Here, we can take the common denominator. First, you can take from the numerator, we'll take v squared over, we'll take for out, for a out you can take, right. Then here we get 25, right, and 11 here, minus 9 over 4, right. Right. Then here we can take common denominator as 44. Then here we get 100. Here 99. D over 11. Right. So this 11 and this can cancel down. 11 we get 4 there. Then here 100 minus 99 is 1. We get D equals v squared of 16a. Here 1 16a, v squared over 16a is the answer, right. Right, question number 2. A smooth hemispherical ball of radius a is fixed such that its rim is horizontal. Uniform rod is in equilibrium, one end in contact with the inside surface of the ball and a point on the rod in contact with the rim, making an angle 30 degrees to the horizontal. So that the length of the rod is 4a by root 3. Also find length of the part of the rod projecting beyond the rim of the ball. Right. Okay, now that question. Okay, now right. This is center. It's a ball, no? Right. So then I draw upper part with dash. Right. Now the rod is placed this way. Right. Now here the reaction will be passed into the center, and here the reaction is perpendicular to the rod. Therefore, they must meet at a point on the circumference of the bar. Okay. Right. So then I draw that. The reaction is this. Here the reaction passing through the point is. Here R reaction here is. The third force is the weight. No. Then the weight should be passed through the point of intersection of these two forces. Why? The reason whenever any object is in equilibrium under the action of three forces, we know they must meet at a point. Right? So this is the point where the weight acts. W. Okay. This rim is horizontal. Therefore, when I join the center and this point on the rim, this should be horizontal one. And also when we draw here horizontal line, that horizontal line should definitely pass through the point this. So that this angle 90, that is because of the geometry. Okay. This is the diagram. So now we are given this angle 30. This is a horizontal line. This is also horizontal line. They are parallel. Therefore, this is 30. This and this being equal because radii. This and this angle should be then equal 30. And we are given the ball is of radius A. This is A. This also therefore A. This is also equal. No? Right. And this is a uniform rod. Of a uniform rod, the center of gravity is at the midpoint. Asking to find the length of the rod. Right. I'll take this length as L. This is L from here to here L. Right. And the length from here to here also L then. No? Okay. So then the whole length of the rod is 2L. Right. So now I can write this length in two ways. What is that? L cos 30. The same length I can write A 2A 2A cos 60. Right. Then by the diagram directly you can use what? The geometry. Right. L cos 30 is equal to L cos 30 means this is L, this is 30. L cos 30 is equal to 2A cos 60. Thereby you can take L. Right. So then you can write by the diagram. By the diagram you can write L cos 30 is equal to 2A cos 60. L cos 30 root 3 by 2. 2A cos 60 half. This and this you can cancel down. Put this L here. Root 3 there. Then 2A over root 3. So this L means half of the length. Then whole length of the rod is 2L. So therefore length of the rod. Length of the rod. 2L no? multiply by 2, 4a over root 3. Right. Ask the next part. Also find the part of the rod projecting beyond the rim. So this is asking. If you take this as x, this x can be found how? X is equal to, right, from here to here, the length of the rod 2L minus. We have to subtract this from here to here, this part. We have to subtract. That part going to be a 2a, this is 30. 2a cos 30. Right, no? Whole length is 2L. From that we subtract this. Right. Then we get x equals 2 times 2L we know. 2L means 4a over root 3. 2a cos 30 root 3 by 2. Right. So then we get x. 2 and 2 you can cancel down. X is a root 3, 4a and 3a. X equals a over root 3. Right? Yes. That we can take that answer. Right. Question number 3. Vector question. Okay, question number 3, vector question. In the usual notation, the position vectors of 2 points A and B with respect to a fixed origin O are 3i plus 2j. Right. And 2i plus 4j respectively. Show that OAB are non-collinear. Let C be the point such that BC vector is equal to lambda OA, where lambda is real number. Find OC in terms of I, j and lambda. Show that if BOC is pi by 2, then lambda minus n upon 7. Right? Okay. This way we can draw the two axes, x and y. X axis into x is I. Y axis into x is j. Here O. Here A. Here B. Right. B has the position vector 2i plus 4j. So the here coordinates 2, 4, no? Position vector of A given as 3i plus 2j, coordinates 3, 2, right? Okay. I'm asking OAB not collinear. Right. I'll take this angle to be beta. This to be alpha. Tan alpha mean, yeah, this opposite side, y coordinate 2. This adjacent side 3, x coordinate, no? Then tan alpha is 2 by 3. Likewise here, tan beta, this is y coordinate 4, x coordinate 2 means this. Then tan alpha, tan beta you can write. Tan alpha is 2 upon 3. Tan beta 4 over 2. Okay. Then you know this 2/3 then here really 2 no. 2/3 not equal to 4 by 2. That's well obvious, no? Here the answer is 2, right? Here 2 by 3.6. They are not equal. Therefore you can write tan alpha not equal to tan beta. This says alpha not equal to beta. Alpha and beta not equal. When alpha and beta not equal, this AOB, right, cannot be collinear. Right, so then you can write AOB cannot be collinear, right, because of this reason. Let C be the point such that BC lambda OA, BC lambda OA, BC lambda OA means, right, BC should be parallel to OA, lambda OA, right. Then asking, right, find OC in terms of IJ and lambda, show that BOC pi by 2, then lambda minus 10 over 7, right. BC vector we can write, BC vector given as lambda OA vector, no. BC vector equals lambda times OA vector 3i plus 2j, right. Right, and then asking to find OC. OC vector you can write, what to see, no, this. What's OC vector this way? OC vector you can write OB plus BC. OB plus BC. Right. OC vector OB 2i plus 4j. BC vector lambda times 3i plus 2j. This way. Then OC vector we can write furthermore like this, taking this I terms together. Here 2, keep I outside, and here 3 lambda. J terms, here 4, 2 lambda is the OC vector. Now we are given BOC pi by 2. Right. When BOC pi by 2, when BOC angle pi by 2. So in this case, right, this C should be here. Then only it is possible for this BOC to be 90. That means lambda should definitely be negative value, right? If BOC 90 mean OB and OC perpendicular, no? Right? OB and OC perpendicular. This implies OC vector is perpendicular to OB vector. When two vectors are perpendicular to each other, you know the dot product between the vectors is 0. So therefore I can write OC dot OB should be equal to 0 because they are perpendicular. OC vector we found here 2 plus 3 lambda I and 4 plus 2 lambda j dot OB vector is 2i plus 4j equals 0, right. So you know how to take the dot product between the vectors involving ij. You have to multiply I coefficients and j coefficients, no, right. I coefficients here we get 2 and this. This gives us 2 times 2 plus 3 lambda, 2 times 2 plus 3 lambda, 4 times 4 plus 2 lambda, 4 times 4 plus 2 lambda equals 0, right. Here we get 6 lambda, here 8 lambda, then there we get 14 lambda, and here we have 4, here we have 16, then 20. Take to right hand side minus 20. The lambda we get minus 10 over 7. This way we can take that answer. Last question, question number 4. Right, number 4 says a uniform rod. AB of length 8A and weight capital W has its end A smoothly hinged to a fixed point. One end of a light inexpensive string of length 4A is attached to the point C on the rod such that AC 3A. And the other end is attached to a fixed point D vertically above A such that AD 5A. And the length of the string is 4A. The rod is in equilibrium, show that the tension of the string is this much. Also find the horizontal component of the reaction at A, right? So here we can draw the diagram. You see we have rod. Right. Now this is the D, here A. This length given as 5A. Right. The string has length 4A. This is 4A. Right. And also AC is 3A. Here this is the point C. This is 3A. 3A, 4A, 5A. That means this triangle obeys the Pythagoras theorem. So therefore right angle triangle. This is a right angle triangle here, 90. Right. Here then length is 80, no? Then the uniform rod center of gravity lies at the midpoint. The root should be longer than this. Right. This is 4A. The whole rod given 8A of length. This is hinged here. At the hinge, single reaction we can write as two components, horizontally X and vertically Y like this. Right. Right. If I take this angle to be theta, of the angle theta, sin cos tan you can write, the tension acts like this T. Right. Okay. Right. Sin theta we can write opposite side divided by the hypotenuse, 4A divided by 5A means 4 over 5. Right. Now what is first asking? Show that the tension of the string is this. To find the tension of the string, we can take moment around A for the equilibrium of the rod. Right? So then you can write for the equilibrium of the rod, taking moments around A. T into 3A is equal to W times, right? When I produce the line of action of W like this, when we drop the perpendicular, this is the 90 angle. Therefore, to take the moment of this W, the required perpendicular distance is going to be this. So you know if this is theta, this is also theta. The length from here to here, 4A. Its opposite side is the required perpendicular distance. It is therefore 4A sin theta. W into 4A sin theta. A and A you can down. T equals 4W. Bring this 3 here. Sin theta we found 4 over 5. Then we get T 16W over 15. Right. Also find what? Horizontal component of reaction at A. To find the horizontal component of reaction at A, we can resolve the forces acting on the rod horizontally. So, if I resolve it like this, here, if I draw a horizontal line here, if this is theta, this is 90 minus theta, this is theta. T cos theta is equal to X, right? Resolving horizontally, resolving forces horizontally, X we get equals T cos theta. Right, cos theta you can write adjacent divided by the hypotenuse, right? Cos theta is adjacent is 3a, hypotenuse is 5a, 3 by 5. Okay, then t we found here 16 w over 15 cos theta 3 over 5. So then we get right 3, and this we can cancel down. X is 16 w upon 25. This way we can complete that question. Okay, right, this is the end of the discussion.